Hello everyone! In today's video, I'll introduce you to 3 tips for making a homemade soldering iron. In the first tip, I'll guide you through an extremely useful trick, transforming an old and used laptop charger into a powerful and versatile tool. The first step is to carefully open up the casing. I'm using a small screwdriver to gently pry along the seams. Now that the casing is open, I'm removing the internal components. We won't be needing the circuit board itself, but the empty casing will serve as the perfect housing for our new DIY tool. I'm putting the 2 halves of the empty casing back together temporarily. Next, I'm taking a drill with a cone-shaped bit and carefully drilling a hole into one end of the charger casing. This hole needs to be wide enough to accommodate our next component. Now for the core of our project, the spark plug. I have a basket full of these, and they are incredibly versatile. I'm selecting one that looks to be in good condition. I'm taking a red electrical wire and using pliers to strip a small section of insulation from one end. This exposes the copper conductor, which is essential for making our electrical connections. I'm tightly wrapping the stripped wire end around the electrode of the spark plug. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I'm stripping the longer insulation from the other end of the red wire. I will attach the stripped copper wire to the threaded part of the spark plug and twist it tightly. I have a small brass connector, and I'm using a screwdriver to remove the screws and the small brass block inside the plastic. I'm attaching the brass connector to the spark plug electrode. This creates a solid electrical contact point, which is crucial for delivering power to the heating element. Now, I'm taking a small AA battery. I'm going to carefully cut open the casing of the battery using pliers. I'm being gentle to avoid damaging the internal components. I've successfully removed the carbon rod. This is a great conductor of heat and electricity. I'm now securing it into my drill. The purpose of this is to sharpen the carbon rod. I'll use a piece of sandpaper while the drill is running to create a fine pointed tip. A sharp tip allows for precise heat application. I'm stripping a new red wire and attaching the stripped end to the center electrode of the spark plug. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I'm threading the other end of this wire, along with the red wire connected to the electrode, through the hole we drilled in the charger casing. This keeps everything tidy and protected inside the repurposed casing, forming a comfortable handle. At the other end of the red wire, I'm stripping the outer insulation. The other end of this wire gets an alligator clip attached, which will be our positive terminal. To prepare for the negative terminal, I will attach a blue alligator clip to the blue wire. To provide power, I'm using a Makita battery. I'm attaching the red and blue alligator clips to the positive and negative terminals of the battery, respectively. This completes our circuit, ready to unleash the heat. I'm placing 2 razor blades on a small piece of wood. When I touch the carbon tip of my homemade soldering iron to the razor blade, look at that. The soldering iron tip glowed instantly, and the razor blades began to heat up and even melt, helping the 2 razor blades stick together. This little device packs a serious punch, effortlessly cutting through the metal. I'm placing a metal screw to the multi-purpose cutting blade on the wooden block. I will connect the blue alligator clip to the screw. When I touch the carbon tip to the screw head, it immediately starts to glow a brilliant orange, making the metal screw firmly grip the utility knife blade. This homemade soldering iron worked perfectly, capable of quickly and efficiently soldering metal. Move on to the next tip. I've got a basket full of used batteries here. We're going to pick out a standard AA battery, as it contains a very important component for our project. I'm carefully removing the outer casing with some pliers, making sure to peel back the plastic and metal layers. This allows me to access the internal materials. This is the core element we need because it's an excellent conductor of electricity and can withstand high temperatures. With our graphite rod cleaned, I'm going to attach it to a drill. I'll use a piece of sandpaper while the drill spins the rod, creating a fine pointed tip. This sharp point is crucial because it will help concentrate the electrical current and generate intense heat precisely where we need it for effective welding. Next, I have a basket full of old spark plugs. I'm picking one out and a plastic connector block. From the connector block, I'm unscrewing and pulling out a small brass connector block. These small parts are perfect for making a secure electrical connection to our graphite rod. I'm taking the brass connector block and attaching it to the spark plug and tightening it. I'm taking a sharpened graphite rod and inserting it into the spark plug connector block and tightening it. Time for the wiring. I've got some red electrical wire. I'll strip a small section of insulation from one end of the wire and then carefully wrap the bare copper around one of the screws of the brass connector on our spark plug assembly. I'm making sure it's a tight connection for optimal conductivity. Then, I'll carefully secure the wire with electrical tape. This is extremely important for insulation and safety, preventing any short circuits during use. To complete our electrical connections, I'm now stripping the other end of the red wires and attaching a set of alligator clips. These clips will allow us to easily connect our tool to a power source. For the negative wire, I'm preparing a white wire and attaching 2 black alligator clips to each end. I have a battery here, which will provide the power. I'm connecting the alligator clips to the positive and negative terminals of the battery. This homemade tool is quite powerful. It's impressive how much heat this little device can generate. Now, I'm trying out my homemade soldering iron on the teapot first and soldering the handle onto it. I'm going to carefully hold the teapot steady and apply the tip of our new tool to the side. You can see the metal glow red almost instantly as it begins to melt the metal and firmly attach the handle to the teapot. This demonstrates just how versatile and effective this simple, recycled device truly is. From discarded items to a functional tool, it's all about creativity and understanding basic principles. Let's move on to the final soldering machine tips. I'm starting with these 2 soda cans. I'll carefully remove the pull tabs. These small metal tabs are surprisingly versatile for various DIY projects, so I always keep them. Next, I'm taking a simple paintbrush. I'll use a pair of pliers to carefully remove the metal ferrule and the bristles, leaving just the wooden handle. This handle will form the base of our new tool, providing a comfortable and insulating grip. I'm taking one of the pull tabs and placing it on the top of the wooden handle. I'll use a fine-tipped marker to mark the positions for 2 small holes on the handle. With the holes prepared, I'm now taking a small screw and a washer to attach the first bent pull tab to the wooden handle. The washer helps distribute the pressure and prevents the screw head from pulling through the tab. I'll tighten it securely with a screwdriver. Then I'll repeat the process for the second pull tab. For the next part, I'm using a piece of bicycle inner tube, specifically the valve stem section. I'll cut around the valve to isolate it, then I'll remove the outer nut and internal valve core. I'm threading the valve section through the pull tab. This modification is crucial, as these will be our electrical contact points. I'm using pliers to tighten the valve nut securely. Then, I'll do the same for the second modified valve stem on the other pull tab. Next, I'm taking a red insulated electrical wire. I'll strip a small section of insulation from one end, twist the exposed copper strands. I'm using a screwdriver to tighten the screw that's securing the wire. I'll repeat this process with a blue insulated wire for the other metal post, ensuring a clean and secure electrical path. To keep all the wiring securely in place and insulated, I'm wrapping the middle section of the handle with black electrical tape. This step is essential for safety, preventing any accidental shorts or contact with live wires while the tool is in use. Now, to connect our tool to a power source, I'm attaching 2 alligator clips. One red for the positive terminal and one black for the negative. I'll strip the ends of the red and blue wires, twist them tightly, and secure them within the jaws of the respective alligator clips. The final component for our tool is a carbon rod. I'm carefully fitting the sharpened carbon rods onto the tire valves, which are secured to our wooden handlebars. These rods will serve as the hot tips of our tool, ready to channel the electrical energy. The assembly is complete and looks quite impressive. With our tool assembled, it's time to connect it to a power source. I'm using a small motorcycle battery for this demonstration. I'll attach the red alligator clip to the positive terminal and the black clip to the negative. This provides the necessary current to heat our carbon rods. Watch this. As I touch the carbon tips to the razor blade, you can instantly see the sparks and the blade glowing red hot. It melts through the metal with surprising speed, creating clean cuts. This is the power of concentrated heat from our simple DIY tool. I'll also try it on a thicker multi-purpose cutter blade. When I touch the carbon rod to the blade, watch how quickly the carbon rod starts glowing red. It works similarly effectively. The carbon rod melts the contact points and welds the two blades together precisely and easily. This project truly shows that with a bit of creativity, you can transform everyday items into incredibly useful tools. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected tools you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.